We're studying IGCSE chemistry and we are learning chemical reactions equilibria 3. Today, our goal is, our agenda is to finish, to look at fertilizers or first practice questions and to look at fertilizers. That's it. Let's start. Just give me a second. Okay, first thing first, fertilizer.
No, Coco, no.
All right, okay. I have this right here on the board. You should be able to see it.
Yeah, but sir, can you zoom in a bit?
Yeah. Fine, question 1.
Ammonia.
Now this is about fertilizers. Okay, ammonia, read the question.
Yes. With sulfuric acid to make a compound which is used as a fertilizer. Write a chemical equation for the reaction between ammonia and sulfuric acid.
Sulfuric acid. Okay. Now what they mean by this is it's a chemical reaction happening, right? Now this chapter does.
The equation for ammonia, it is
yeah. How do we solve this?
Ammonia, it is NH3.
NH3.
Yeah.
Okay, now let's see. If they're going to react, they must be aqueous. So we'll write NH3 aqueous and sulfuric acid H2SO. What is sulfuric acid? Tell me.
Sulfuric acid.
Sulfuric acid is?
Sulfuric acid is H2SO4.
H2SO4. You need to memorize this by heart. Next, add these together. What do I get? Now, this question you haven't really done it. Perhaps this may be a bit difficult. Should I help?
Yes, sir.
Okay. Okay. Now, so what happens is the reaction between ammonia and sulfuric acid will give us this NH3 to NH4 to SO4. And this right here is called ammonium sulfate.
Ammonium sulfate?
Yes.
Okay.
Now you need to write this down. And another rule which you need to know is all ammonium salts are soluble. Is that clear?
Okay.
Write this down in your notebook. So what are you going to write? The question first is reaction between this part, this one, reaction between ammonia and sulfuric acid. Write the answer, then write the notes. This one. And put the caution symbol or something there to revise later that this is important.
So all ammonia are soluble?
Ammonium salts, yes, all of them. Perhaps you can take NH4Cl. You can take NH4.
Are they all in aqueous form?
Yeah, so soluble means aqueous form. Yeah, aqueous. If they were not soluble, then it would be the solid form. Okay, so they are aqueous. Soluble means aqueous. Let's write it down. Soluble slash aqueous. Done. The next thing we're looking at is use of ammonia. What was this? This was the reaction between ammonia and sulfuric acid. Now we're looking at uses of ammonia. Now these are notes. These are now, we're not really practicing right now. We're doing some questions and writing the important notes.
So you will keep a class tomorrow or not?
I think yes.
Okay.
Okay. Now we're looking at the uses of ammonia. Let's start here. Let's look at this question actually. Okay. Okay. The first use is making fertilizers.
Making fertilizers?
Yes. Okay. Now making fertilizers. Second one is making nitric acid. Nitric acid. What is the name for nitric acid? HNO3. Aqueous. That is nitric acid. Done. What is the use of sulfur dioxide? Uses of sulfur dioxide. I'll tell you.
Okay.
Now the uses of sulfur dioxide are first one is in contact process to make sulfuric acid. Remember, how do we get sulfur trioxide? This is the equation, SO2 plus.
Yeah, we wrote it.
Yeah, this one. That is the second stage. The second stage of the contact process to give SO3. The first stage was S plus O2 gives us
Tri means 3, right?
tri. So sulfur trioxide, yes. And then the sulfur trioxide reacted with H2SO4. Okay, first write this down, uses of sulfur dioxide. And
Okay,
I'll talk to you about after the rest of the things afterwards. Let me finish this. We get H2, H2. And the second use over here is as a food preservative. Food preservative.
So it's make or making?
Where?
First one.
Which one? Make, to make. No, contact process for make. Let's wait, to make sulfuric acid. Yep. In contact process to make sulfuric acid. And the second one is food preservative to preserve food, basically.
To make.
To preserve food. Food for it. Let's just say food preservative. You know what it means, yes? What is the meaning of food preservative?
So what food they will preserve?
What is food preservative? Preservative. This word. What is this? This means to to make sure, or let's say to make sure food lasts long. Please write this after.
Sir, your voice is lagging.
Now can you hear me?
Yeah, now I can.
Okay, so this now can you hear me? I think if you can, then just write what you see on the board.
Still your voice breaks between.
Now you just have to write what you see on the board. Write it in your notebook.
Yeah, done.
Done. All right. That's good. Now let me see if there's anything else. To measure sources. Okay. One more thing you should write is sources of sulfur. Now you should realize that this right here is about the contact process. Okay, so give the heading contact process on these two. On top of these two. This one was about Haber process. Now the sources of sulfur are underground deposits slash ores, which is called this.
So still your voice is lagging.
Try to rejoin the meeting.
Okay. Sir, can you hear me?
Now can you hear me?
Yeah, sir, now it's clear.
Perfect. Now the next thing is write the uses of sulfur dioxide. These are the uses of sulfur dioxide. 4. In the exam, you'll usually be asked 2 or 3 maximum. So please remember all of these. Now this one, the first one is not important because this is common sense. Okay, these 3 are important.
So what bleach? To make bleach?
Bleach, yes, to make bleach. Make bleach, just a second. Or you can also say bleach, and 5. There's another one which I remember, which is insecticide. Insecticide. Bleach. Done. Now, finish writing. Tell me when you're done.
Sir, should I write the sources of sulfur?
Yes. Now you should also write this part. Kills microbes. Done. You should be done by now. Can you hear me?
Yeah, I'm done.
Now, did you write this part? Like, kills microbes and bacteria and fungi. This part.
Yeah.
Yeah. Okay. Now you should know that this is enough. Kills microbes. But if they ask you bacteria, then you should know that it's also about food preservative. Perhaps an MCQ. Now, one more thing you should know is, write this down. Why is sulfur trioxide not directly added to water in contact process? Now, Niranjana, what do you know about the contact process so far? We know that there are 4 stages. How many stages?
4 stages.
4 stages. The first one is, what is the first stage? What is the first stage?
Voice is lagging.
Now, can you hear me?
Oh,
What is the first stage?
yeah, now it's okay.
So,
First
what
stage
yeah.
is converting sulfur into sulfur dioxide.
So, making, let's say, making sulfur dioxide. Dioxide. What are the uses of sulfur dioxide? Tell me. Uses of sulfur dioxide. Tell me.
Uses of sulfur dioxide. Sulfur dioxide, it is used to make bleach, to make insecticides, and wood manufacture, and then for preservation, it kills the bacteria, microbes, and fungi. Yeah.
All right. Now read the second and the third stage. What are the names? First stage was this. What is the second stage?
Second stage is converting sulfur dioxide into sulfur trioxide.
Right. Okay. Third stage is?
Third stage is converting sulfur trioxide into oleum.
Oleum. Now the fourth stage is?
Fourth stage, it is converting oleum into sulfuric acid.
So it's not just converting. I don't like the word converting. I think you should use the word reacting, or perhaps producing, or the word which I need in the last stage is dilution. What is it? Read it out.
Dilution.
Dilution of what? Dilution of oleum to sulfuric acid. Is that clear? With water. Dilution of oleum with water to sulfuric acid. Fine. Now you tell me, why do I make it like this? I could have done this directly In the third stage, I could have done SO3 plus H2O. What would this give me? This would give me H2SO4. That is what I wanted. So why am I doing this extra step here? Why am I not making it directly? Do you know the answer? Why am I doing 2 extra steps? I'm adding SO3 not to water but to sulfuric acid, and then I'm adding oleum to water. Why not directly sulfur trioxide to water?
Because it's concentrated.
Not really, no.
Then-
Okay. Any other guesses? Have you done this in class?
Because it needs a lot of heat, that's why. So we
No.
have to heat it.
Read the question. Read the question.
Okay. Why is sulfur trioxide not directly added to water in contact process?
Okay. The crazy thing is, this this would produce, let's just say, adding SO3 directly to water makes, or let's say creates or makes an acid mist. What does it do? Makes an acid mist, which is dangerous. Which is dangerous.
So what is acid mist?
I'll tell you what it is. Just a second. Second, why? Because the reaction is too, let's say, okay, I'll give you the exact word in a second. Try the first part.
Okay.
I can't remember the word. It's too. I can't say it's too reactive. I can say the reaction is too reactive, but that's not a good word. There's another thing here. Just a second.
Right. So I can't see the question.
Done writing. Now we have to move on. Now you should also write. These the stages of contact process as well. Two. Oh yeah. Okay, I got the word. Two. Violent. That's the word. Okay. Yep. Is that clear? Any questions?
One minute. So now can you tell me the meaning of mist?
Acid mist. Yeah, I'll show it to you. Now, have you written the stages of the contact process?
That we wrote yesterday itself.
Are you sure? You don't have to write it again. I remember you did write it, but okay, you have.
Yes, sir.
Fine.
Yesterday
Okay,
only
then
we
fine.
wrote all this.
Good. Good. So please remember it, okay? Revise it. Now I'll show you what acid mist looks like. Look.
Okay.
Can you see this?
Mhm.
Or let's a better image is this. Look, it's like like a spray. Now, you don't want acid just spraying, let's say spraying all over the place. Right? It's like a blast. Acid is thrown away in all the places, in all directions, which is dangerous. So people would get acid on themselves. We don't want this. Or I'll show you a better one. Imagine something like this. Look, can you see this? Can you see this power plant here? This fog, mist slash fog, same thing. Ranjana, can you hear me? Mist slash fog,
Yes, sir.
same thing. Just imagine that this whole thing is made up of acid, which would be dangerous, yeah?
Oh,
So you don't want this to happen. Acid, imagine sulfuric acid going away in the air like this. So we call it acid mist. Clear?
yeah.
Now I don't think you're going to forget this, yes? Because now you see this dangerous plant here, which this is how it looks.
Yeah.
Perhaps that's good. Okay. Please don't memorize things, understand what's happening. Now I hope you have written all of this. Yes, sources of sulfur done.
Mhm.
Okay, fine. Now let's look at some other things. Just a second. Now we can practice questions, but I'll actually just give them to you as homework. But I want to show you
Okay.
something about fertilizers. Just a second, because whatever you're writing is also important.
മൂക്കിന്റെ സൈഡിൽ കണ്ണും തലയും വെക്കണം. തണുപ്പിന്റെ അല്ല, എനിക്ക് അവിടെ ഭയങ്കര ഇത് വേന എടുക്കുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ
Look at fertilizers. Now the first thing first is we look at common fertilizers. Now common fertilizers are, just a second. First one is ammonium nitrate. Ammonium nitrate. What does it look like? This is NH4, NH4NO3. Why is this NH4NO3, Niranjana? Why is it not NH4 2NO3 or NH4NO3 2? Why not? Which of these do you think is correct?
I feel like the first one.
Why?
Which it feels, I don't know, but first one feels right.
It's not. It doesn't work like that. The thing is, you look at the charges. You have to memorize them. This is very important. You memorize the charges. Ammonium of ammonia is always +1. Okay, and NO3 is always minus. So how do you balance them? Cross it out. So one comes here, the one goes there. What are you left with? NH4, NO3. Is that clear?
Mm-hmm.
Right? Any doubts here?
No.
So don't just say I don't know. That looks fine. Yeah, I need a reason for everything. Is that clear? Right? That answer is not acceptable. Now the next one is okay. Now another common. This is done. You know all of this. Okay. Just a recap. Another common fertilizer is called ammonium, which we looked at already. Sulfate. Can you tell me the formula for this? Come on. Ammonium sulfate formula.
Ammonium sulfate, it is NH4 bracket 2
Bracket 2.
SO4.
SO4. Yeah, why? Because SO4 is 2 minus. Done. Now,
So
okay,
can
these
you
are the.
hear me?
Yes, I can hear you. Why ammonium nitrate preferred over ammonium sulfate? That's a question. Why is this guy preferred over the other one? The answer is, I'm restarting the meeting, rejoin quickly. Don't waste
Okay.
time. Now we're continuing on fertilizers. Yeah, please write these down. The whole thing down. Common fertilizers. This is the point. This is fertilizers and question. Why is ammonium nitrate preferred over ammonium sulfate? Because this guy contains more nitrogen. Is that clear? Done.
So were you saying something this all time?
No, I was just saying, write this down on your notebook.
Oh, okay.
I hope you have written it because we'll do a question on this.
I'm sorry, I'm writing that.
Right first, okay.
Done, sir.
Done. All right, that's fine. That's good. Well, yeah, okay. Now done. Let's focus on the question here. Read the question.
Well, for the best rose flower, the fertilizer should contain high proportion of potassium. This fertilizer is best for producing rose flowers.
Read the first one as well. First
To
line.
grow rose plants, a fertilizer contain nitrogen, phosphorus, and potassium is often used.
Right. Okay. Now, what is the answer to this question? Think.
I don't know.
Don't know?
What is
Okay,
it?
I'll tell you. First thing first is we underline what are the important things in the question. Underline. Don't forget, underline everything in the exam. High proportion of potassium, that's needed. And what should the fertilizer contain? Nitrogen, phosphorus, and potassium. Now you tell me which of these has high proportion of potassium. Now you first tell me what is N over here.
N is for nitrogen,
P is for
potassium.
phosphorus. Not potassium, never. P is for
Okay.
phosphorus. And what is K?
K is for potassium.
Potassium. You tell me which of these four options have the high proportion of potassium. Is it C, is it D, is it A, B, which one? Which of these? Like, let's choose which ones have high.
15.
Which one? Well, it
25.
can't. Go on, tell me.
No, it's 25.
So A is 25, that means it's high. Okay, B is also a bit high, it's 20, but 0 and 5 are low. So we can't take these. These are wrong then, right? Make sense?
Yeah.
Then it has to be either this guy or this guy. Now read the first question, read the blue part on the first line. Containing nitrogen, phosphorus, and potassium, right?
Yeah.
It must have all three of these. Now you tell me which of these options have both you have all three.
B.
B. So the answer is B. Got it?
Yeah.
This is wrong. Okay, so this is why, because this is low N. This is because no P. So this is the correct answer. I hope that's clear and fine. Okay. Let's look at another question on this topic. We'll start a new question. We're starting practice now again. So let's start this one. Read the question.
Sulfur is used to make sulfuric acid. In the UK, the annual production of acid is about 2.5 million tons. The reactions in the manufacture of sulfuric acid by the contact process are shown below.
Okay, read the first this one. Question 2, part 1.
Is
A part 1.
large-scale source of element sulfur.
Element sulfur. What is the answer?
So I didn't understand the question. Give a large-scale source.
Say that again, louder.
So what does give a large-scale source mean?
Source. Read your notebook. Find in your notebook. Find source. What is source of sulfur? Tell me.
Ah, okay. Source of sulfur.
Yeah.
When they give large-scale source, I got confused.
So what is the answer?
It's from underground or fossil fuels.
Underground what?
Underground ores.
Ores.
Or
But that,
deposits.
yeah, but don't write that. Do one thing. Cut it out of your notebook. Cut it.
Why?
Because that's not a large scale source. Okay.
So what
Or
about
don't cut
fuels?
it. Don't cut it. Just write in front of fossil fuel. Write large scale. Don't cut anything. Just write in front of fossil fuel. Write large scale. Is that clear? The answer is always going to be fossil fuel.
Done.
Okay. Now you can also say underground ores. What is the name of the ore? Tell me.
It is
Galena.
Yeah.
Galena. It's called Galena. Now Galena is actually a beautiful person, and she gives us all the sources of sulfur, right? So you can also write that over here. That's no problem. Or you could say or. When you write underground ore, you should write underground ore, or let's say Galena ore. Is that clear? But I would prefer that you write the answer, the first one, fossil fuel. Understood?
Fossil fuel now.
Yeah, but what if they ask you fossil fuel is one, give another one? Then what will you say?
I'll give the other one.
The other one, yeah, easy. Now state another use of sulfur dioxide. Tell me. Use of sulfur dioxide.
Use of sulfur dioxide?
Yeah.
Use of sulfur dioxide. It is food preservation. It kills bacteria, fungus, and
Food preservation. Right, food preservation. Easy, good. Good, so good. Done. Next one. How sulfur changes sulfur dioxide? Now you don't know this one. Perhaps you do know. Let's try it. The answer is burnt in air. Okay. Write it down in your notebook. Write the question, write the answer in your notebook. Write the whole thing. Burnt / roasted. Or don't say roasted, just say burnt in oxygen / air. Now this is again in bracket, right? stage one. Stage one of what? Contact process.
Okay, now write it.
So see, now they're asking you the name of the reaction. We know what stage one is. We know it's going from sulfur to sulfur dioxide, but the name of that reaction is burning it in air. Because we know that S reacts with oxygen, yes? This reacting with oxygen is called burning. Is that clear?
Yeah.
Reacting with oxygen is always burning. What if I react carbon with oxygen? What will you call this reaction? What is the name of this reaction? This will be called burning carbon in air. Burning carbon in O2, sorry, not air, oxygen. That's the exact answer. Oh, what is it reacting with? Oxygen. So that's it. Is that clear?
Yeah.
Now, just write one more thing here. Just one more thing, which is combustion. Because this is the exact word. Right? Combustion. And in the exam, you should also write combustion in oxygen. Forget air from here. Remove air. Cut air.
So combustion is when carbon dioxide combines with oxygen, right?
Carbon reacts with oxygen, but it's not just for carbon, it's for everything. Whatever reacts with oxygen is called combustion. Is that clear?
Okay.
Yeah, makes sense. So combustion was reacting with oxygen or enough oxygen. Okay. Now next up, name the catalyst used in reaction 2. Answer. Catalyst used in reaction 2.
Name a catalyst used in reaction 2. It is iron.
No. Check your notebook for contact process catalyst.
Or contact. It is V.
What is V?
Vanadium.
And after that,
Oxide.
so you have to say the whole thing. Vanadium oxide. What is the whole thing? Vanadium 5 oxide. Have you written this?
Yeah.
Vanadium 5 oxide. Is that in your notebook? Vanadium 5 oxide. That's the answer. Not V. That's wrong. Not V. Let's say V oxide or vanadium oxide. Vanadium 5 oxide. This is the exact answer.
Let me check on it. Vanadium 5 oxide?
Yes. Vanadium 5 oxide. Written? Is it written there?
Yeah.
Now read the next question. Come on, hurry up. We don't have time. I think the class is over now. We're going to finish this and that's it.
Okay.
Read the fifth part.
Reaction 2 is exothermic. Why is a catalyst rather than a higher temperature used to increase the rate of reversible reaction?
Yes, answer. Check your notebook and answer, or answer directly. I need the correct answer. Yeah, you have the answer in your notebook.
So the increasing pressure it favors endothermic and heat is absorbed to degrees temperature.
Say that again.
Is it because increasing the temperature favors endothermic and no, it's for exothermic, right? How catalyst rather than how
You have to go to the part where we talk about why are conditions chosen, reason for choosing condition for contact process.
high. The higher temperature increases the rate of reaction.
After that,
So faster reaction, we take a maximum compromise of temperature 450 degrees Celsius.
there's something missing in the middle. Say it again. Say the answer again.
So it's written higher temperature increases rate of reaction. So to have faster reaction, we take a compromised temperature of 450 degrees Celsius.
Okay. Then again, there's something missing. Read from the beginning, or I'll show it to you. There's one part missing.
Lower temperature favors exothermic reaction, more NH3, but higher temperature increases rate of reaction. Like
Okay.
that I wrote.
Right. I'll show you. I'll show it to you. Just a second. Now rewrite this answer. Okay. Okay. Yeah. This is your answer. Rewrite it in your notebook right now. Just a second. A shorter answer which you can memorize. This. The question which you need to say is, the question which you need to write is, why is catalyst rather than higher temperature used? This one. Over here. Yep.
This is for Haber process, right?
No, contact process.
Okay.
It's for both Haber and contact. It's the same thing for both. Both of them are exothermic. Haber and contact. So you have the blue part question and then the answer. Write it down.
Sample learn ಆಗುತ್ತೆ.
Written?
Done.
Done. Good job. Just a second. Okay. Now read the next question. Niranjana, read the next question.
Okay. Wait. Sixth, write a word equation for reaction.
Reaction 3. Yes,
Yeah.
you're right.
What equation it will be?
Reaction 3.
Sulfur trioxide, sulfur plus So how will we write the word equation here?
Tell me the chemical equation first.
Chemical equation, it will be SO3 plus H2SO4 gives H2S2O7.
So, okay, what is the name of SO3?
Sulfur.
Not sulfur, no. SO3. Sulfur trioxide, yeah? Let's write it down. So you said SO3 plus H2SO4 gives
So,
us,
but it is word equation, right?
yeah, I'll tell you, just a second. This plus gives us H2O7, yeah? So what is the name of SO3? This is sulfur trioxide. You know that. And what is the name of H2SO4?
A hydrogen.
No, don't do that. Sulfuric acid.
Sulfuric acid.
Yeah, please either write this down right now. Sulfuric acid. And what is H2S2O7? What is that guy? That is oleum.
Oh.
So write this, wherever you have written this equation, just write this guy as well, near it.
Okay.
Sulfur trioxide plus sulfuric acid gives oleum. Now you know the names of these guys. SO3 is sulfur trioxide, H2SO4 is sulfuric acid, H2S2O7 is oleum. Because if you know the chemical equation, you can write the word equation. But if you have any difficulties, there's no problem. Just write this down. Done?
Done.
Okay, done. H2, yeah, done. Now tell me the symbol equation for reaction 4, stage 4.
For stage 4, it is H2S H2S2O7 plus H2O gives 2H2SO4.
Yeah, that's correct. So you get the mark. Good job. Okay. Yeah, that's it. So all of these are correct now. The only thing you got wrong here was this guy, fifth one. But that we have done that already. Now, how can you? I'll just show you where I wrote this guy here. Just a second for the other reactions as well. Look, Niranjana, can you see this? The classroom, Google Classroom, GCR on the screen.
Yeah.
Now you have to go to your class. Yes. I hope you can see it. Go to classwork. Yeah, open your class, go to classwork, and then you should find chemical reactions and equilibria 2. Can you see that?